Okay, so now we're going to do the IEEE format, and we're going to be converting from the IEEE. So in this case, we're going to do first IEEE to just a normal number or number. One thing I've been writing with a pencil nowadays because Notability made a new update, and it makes my letters look awful as it's in here. So that's why I'm writing with this guy now. So that, whatever. We're gonna first go and take a look at our cheat sheet, which quite honestly has all the steps we need to understand this. So in this case, we have, for example, the numbers, right? The IEEE numbers. And let me just go to the next, to the like the ETE cheat sheet, sorry. So in this case, this number is going to be the first exercise we have, A, and I'm going to explain to you how it works. So basically, we have three main components in this case. We have our sign, which is given by the red little underlined number, which is 0. Whenever we have a 1, it will be negative. Whenever we have a 0, it's positive. Then we have our character, which is basically just this big number. Then we have the bias, which is the actual length of how many bits we have in our character. So in this case, we have 8 bits. So 8 bits minus 1 and the minus 1 is going to give us 127. That's how we get the bias, 8 being the amount of digits we have here. Then we have the mantis, or the mantis, which is this long boy over here. And this boy is just taking as is. We just take the numbers up until we have our last 1. So that meaning we can only get this guy, only these 3 numbers. We don't consider this zeros because they have no 1s there. So we're gonna take these numbers and we're gonna convert them into a decimal value, of course. And then from there, we're gonna the stellen is just like the bias in the sense that we take how many digits we have. So in this case, it's 4 times 3. It's going to be 12. And then 12 basically gives us 2 times 2 to the 12. It's going to give us 4,096. So once you've been finding this, you can find the exponent, which is basically the character converted into decimal, minus the bias, which is this guy, gives us a 10. And now we're able to just put it here, basically. That's pretty much how it's supposed to go. Let me just open my computer real quick so we can check the notes while we're doing this. So let's go back into, just give me a second, guys. I just need to open this up. Go to mini clausura. No, mini clausura. Where is this? It's a bit deep down there. Yeah. Mini clausura. Let's go downstairs. Down. Why am I saying downstairs? Down. Scroll down. Give me a second, guys. Okay, good. So basically, we have an error in our thing. This shouldn't be BS. This should be exponent. So I just looked at it and was like, this is not right. So I just write here exponent. Perfect. And now we can start looking into our problem here. So let's start off with, let's go to, oops, not here, let's go here. Let's start with number 2, because number 1 is already given in the cheat sheet. Let's do number 2. So number 2 is quite simple. You just have to take, in this case, number 2. We have to take the big number, right? So we're going to write the big number. So it's going to be 1, and then 0, 0, 0, 1, then 1, 0, 0, 1. And then again, 1, 0, 0, 1, 1, 0, 0, 1. And now just a bunch of other zeros. So in this case, it'll be 1, 2, 3, 4. And then 3 more. 1, 2, 3, 4. And then Am I correct? Yeah. 1, 2, 3, 4, and then 1, 2, 3. It's important to understand that the amount of numbers in this guy has to be equal to 32. So we count this. We have 1, and we have 4, 4, 4, 4, 4, 4, 4, and then 3. 1, 2, 3, 4, 5, 6, 7. 7 times 4 is 28. And 28 plus 4 is 32, as you guys can see. So in that logic, we have 32 bits. That is why we have that's a standard in a sense. As you guys can see, we're just saying, okay, we have 32 bits, of which 1 is being used by our sign. And then from 30 to 23, if we just take that, it's going to be 8 characters for our character, basically. And then the mantissa has the rest of them, basically. So let's just start doing this. Let's go ahead and start with this. Let me just open real quick my cheat sheet over here, my mat and my computer, so I can just go along and I cannot forget all the formulas. So it's quite important to know the formulas in this case. So in this case, we're going to start off first with the character, okay, and the BS. So let's go ahead and start doing that. So the character is given by the first 8 bits, as we already noticed. We already stated here. It's going to be the first 8 bits. And the character in this case, if we convert this binary number into decimal, it's going to give us, let me just put in my calculator real quick, because I don't want to do this in the video. It's going to take too long. In decimal, it's going to be 153. 153. So this gives us our character. Now we want to find our BS. And the BS we already know is the amount of digits that we have from here to here. So we have 8 digits. So I'm going to write 2 to the 8, which is the number we found, minus 1, and then minus 1. That is a formula. So now let's do that in the calculator. Minus 1 and then minus 1. This is going to give us 127, meaning our exponent is basically going to be the character minus a BS. And this is 153 minus 127, which in this case is 26. We have found that. We're going to keep on going. We want to go now with our mantissa that we already stated. I already told you what a mantissa is. The mantissa is the rest of the numbers. However, we just take into consideration, well, basically, oh, I think I messed something up here. Yep, I did a big mistake, guys. I'm sorry. I did a mistake when calculating the character. It should be over here. And I just skipped this for a whole bunch of numbers. So let's start from there. Again, let's do it real quick. Character. This is why it's important to always be aware of what you're doing, because imagine I'm doing this in the test and boom, you're dead. So, oops, and just really quickly write this in binary. 001, 1, and then decimal. This is going to be 25, basically. And then, well, let me just write the whole number so you guys can actually see it. Just copy this. Gosh, this is a bit too difficult to put in there. Okay, so now we have fixed this. That was a bit of a struggle. Now let's do the BS is going to be the same thing, because we already calculated. It's still going to be 8 digits, so it's going to be minus 1 is going to be 127. So now we can do exponent, which is char minus BS. So it's going to be 25 minus 127. In this case, minus 102. So we can write minus 102. Now we're done with that section. We can start with going with the mantissa now. So the mantissa, and that's in this scenario, we're going to take just this 8 numbers again. you should go up until the first one, up until the last one that you see. And that's going to be basically your number, or the last, not really the last one, rather the last block with one. So for example, if we had a 1 over here, if we had it, we would have to take this block as well, right? But we don't have a 1 in this case, so it's going to just stay like that. So now we take the mantissa now. Mantisse. And it's basically this big number, right? I'm going to put it over here. And if we calculate this in decimal, it is going to give us 1001, 1001. And, decimal is 153, right? So now we gotta find the Stellen, or slots, or whatever we're gonna call them. In this case, we have 8, so 8 to the 2 to the 8 is gonna be what? Oops, 2 to the 8 is gonna be equal to 2. 2 to the 8 is gonna be 256, basically. Now we want to find our M, the big M, and the big M is given by doing this, taking the basically the mantisse, and then under it we put the Stellen. So let's do that real quick. We go here, mantisse is 153, so M 153. Over here is 256. Let's calculate that. 153, 256. This is gonna give us 0.5977, something like that. Now that we have calculated this, we know that this Vorzeichen or sign is going to be negative because we have a 1. So Vorzeichen is minus. And we're pretty much done. Now we can actually build our number. If we look at our cheat sheet, this is the actual formula we need to find the number. So we can go here and let's write it down. -1, then we write the V here, which in this case is a Vorzeichen. Then we do times, and then 1 plus the big M times 2 over the exponent. In this scenario, we're going to write -1, then the V, which in this case is, let me find it, it's going to be 1, it's a Vorzeichen, because as you guys can see, we have 1 here. So it's going to be 1 here. We can just write the 1 here if you want, guys, I wanted to. And then times 1 plus 0.5977 times 2, an exponent in this case, is minus 102. So in this scenario, and what we're going to turn out with is, hold on, let me just open my exercise here with a solution to verify that I did everything correctly. We're basically going to get the following. You put this in the calculator, we get -1 to the 1 times, 1 plus 0.5977 times 2 to the minus 102. Basically, we get a bunch of zeros, but if I change the number format, fixed 9 maybe, no, number format scientific 9. You have to have your calculator in a scientific form to the 9th power, otherwise you're going to get zeros if you have the fixed one, the fixed version. So we're going to have at the end minus 3.15090767 times 10 to minus 31. Let me just verify the numbers. Yeah, that's pretty much what we get as a number, and that's pretty much how we convert an basically an IEEE format to an actual number. In the next video, we're going to do the IEEE format, but the other way around, from a number to IEEE format. So yeah.